Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello students, today we are going to discuss 10 MCQs from the chapter Current Electricity. So let's start with the first questions. Welcome to Bohdi Park NEET and J Academy. To access the study material, you can download the app. The link is mentioned in the description. So let's start. Look at this first question. Following figure shows cross sections through three long conductors of the same length. Material length is same, material is same means resistivity same, with a square cross section of edge lengths as shown. Conductor B will fit snugly within conductor A, means perfectly it will fit, and similarly conductor C will perfectly fit within B. What is the relationship between their end to end resistance? So you see the cross sectional area of first conductor, cross sectional area of second conductor, and the cross sectional area of third conductor we have to consider, and the length is same, material is same, so resistance is proportional to, using this formula, rho into L by A. So resistance is inversely proportional to A. So we can say R1 is to R2 is to R3 is equal to 1 by A1 is to 1 by A2 is to 1 by A3, where A1, A2, A3 are cross sectional area. So cross sectional area is clearly mentioned in the diagram. It is the shaded portion. Okay, so what is the area of shaded portion of conductor A? This shaded portion that we have to calculate. Now you look at the conductor B. The outer perimeter of B will perfectly fit inside this empty region of A. So the area of first is side square, which is root 3A whole square, minus the area of the empty region. The area of empty region is same as outer area of B, which is root 2A whole square. So this is 3A square minus 2A square. It will become A square. Now similarly, what is the area of second? So area of second means the outer area, which is root 2A whole square, minus the empty area. This empty area is same as C, which is A square. So 2A square minus A square, so that is A square, and the area in third case is a side square, so which is A square. If you observe, the cross sectional area of all the three are same, equal, so we have all resistances equal. Okay, done. Next question. Now look at question number 2. We have two wires of resistance R1 and R2 having temperature coefficient of resistance alpha 1 and alpha 2 respectively. So we have to consider series combination of these and effective temperature coefficient of resistance. So we have the formula R equivalent is equal to R1 plus R2. So we can use the change in resistance, change in equivalent resistance is equal to change in R1 plus change in R2. Now change in equivalent resistance can be written as, now use this formula, you know R2 is equal to, delta R is equal to R1 into alpha into delta theta. Change in resistance is equal to initial resistance into coefficient of temperature coefficient of resistance into the rise in temperature or change in temperature. So same formula will apply here. So delta R equivalent can be written as R equivalent into alpha equivalent into delta theta. So delta R1 is equal to R1 into alpha 1 into delta theta plus delta R2 is equal to R2 alpha 2 into delta theta. Delta theta cancels, so we have alpha equivalent is equal to R1 alpha 1 plus R2 alpha 2 by R equivalent. So alpha equivalent is equal to R1 alpha 1 plus R2 alpha 2 divided by R1 plus R2. So that is our answer. Now next question. So look at this question number 3. We have two wires of equal diameters, resistivities ρ1 and ρ2, lengths L1 and L2 respectively are joined in series. The equivalent resistivity of the combination. So in this case they are in series, so same formula we'll use. So R equivalent is equal to R1 plus R2. R equivalent can be written as rho equivalent into total length, which is L1 plus L2 by area of cross section. You can refer this diagram. Suppose this is the first conductor and this is the second conductor. Length of first conductor, length of second conductor, and they have the same cross sectional area. So this is the combined conductor of the final conductor. The length is L1 plus L2. Then R1 is equal to ρ1 L1 by A, R2 is equal to ρ2 L2 by A. So A cancel. So rho equivalent is equal to ρ1 L1 plus ρ2 L2 by L1 plus L2. Now next question. Look at this fourth question. We have n rows each containing m cells in series. So it is like a grid. So you have so many cells. So they are arranged in a grid. So grid will look like this. This is suppose one cell, then another cell, then another cell. They are connected in series. So like this we have m cells in series. Now this is one row, and like this how many rows are there? N rows are there. So if we consider one row, so what is the equivalent EMF in one row? It will be equal to ME, and equivalent resistance, internal resistance will be MR. And like this we have n rows. So final equivalent EMF will be ME, and final equivalent internal resistance will be MR by N. If total number of cells are 24 and internal resistance 0.5, so maximum current is, so now we have, it is connected across external resistance of 3 ohm. So we know this concept is the external resistance and internal resistance, when both are equal, current is maximum, power is also maximum. So current is maximum when internal resistance and external resistance are equal. Okay, total internal resistance is equal to external resistance. So what is the total internal resistance? It is M into R by N, and that is equal to external resistance, which is 3. So M by N into small r, which is 0.5 is equal to 3. So M by N is equal to 6. And one more information is mentioned, the total number of cells, which is 24. So total number of cells is M into N. So m into n is 24. So m can be replaced with 6n. So 6n into n is 24, or 6n square is 24. So n square is 4, or n is equal to 2. When n is 2, m is 12. So 12 comma 2, third option. Okay, done. Next, look at question number 5. We have 8 cells marked 1 to 8, each of EMF 5 volt, inter resistance 0.2 ohm, and they are connected as shown. What is the reading of ideal voltmeter? So ideal voltmeter means it will not take any current. So let's draw the simple circuit. Let's combine all the cells. If you see, the negative terminal of 1 is connected to positive of 2. Similarly, negative of 2 is connected to positive of 3, and so on. 4, 5, 6, 7. They are all connected in same order. So the equivalent of these 1, 2, 3, 4, 5, 6, 7. Equivalent EMF is 7E, and equivalent inter resistance is 7R, and this single 8 cell is single here, so it is E, inter resistance is R. Now voltmeter is connected like this. So it is ideal voltmeter, so it will not take any current. So current is 0. So whatever current will be there in the circuit, it will not go here. So now you see plus is connected to minus. So these two cells are also in the same order. So we can find the current now. So equivalent EMF, they are in series now. So because no current is going here, so our equivalent circuit will look like this. So I is equal to 8E by 8R, which is equal to 5 by 0.2. So 25 ampere. So current is 25 ampere. Now the voltmeter reading is potential difference between A and B. So you see the current is going A to B. So it is a discharging cell. 8th cell is discharging, and we can use the Kirchhoff's law. VA minus VB is equal to minus E plus IR. So that is minus 5 plus 25 into R, which is 0.2. So minus 5 plus 5, that is 0. So 0 is the answer. Done. Now next question. Now look at sixth question. The magnitude and direction of current in the circuit shown is. So we have to find that current in this diagram. So I will draw the circuit once again. It is like this. This is 1 ohm resistance, and then we have one cell over here, another cell, another resistance, then another resistance, 3 ohm, and this is 2 ohm, 4 volt. This point is E, this point is A, this point is B, and C and D. So this plus terminal and plus terminal are connected, so they are opposing each other. So 10 is greater than 4, so the equivalent will be difference, 10 minus 4. So we can consider the equivalent like this. So this is the equivalent. It is 6 volt, 10 minus 4. Now we can find the current. So all these resistances are in series. So we can write 6 is equal to I into R equivalent, which is 1 plus 2 plus 3. 6 is equal to 6I. So I is equal to 1 ampere. So now the direction of current. So this is dominating. 10 volt is dominating, so the direction of current will be like this. So A to B via E, through E, A to B via E. 1 ampere A to B through E. Okay, done. Next, seventh question. N identical cells are joined in series with two cells A and B in the loop with reversed polarity. So they are reversed. So total N cells are there. So same polarity cells will be same polarity or same order. Cells are N minus 2 and reverse polarity order is equal to 2. So if we draw these cells, we get equivalent of same polarity will be N minus 2 into E and interresistance N minus 2 into R. And with reverse polarity, it is 2 into E and equivalent resistance 2 into R. Now they are forming a loop joined in series in a loop with reverse polarity, EMF of each cell E, potential difference across A or B. So let's join this. Now it is a loop. So the equivalent, now if we assume this is greater, because N is greater than 4, so this will be greater, so it will dominate. So current will be like this. So we have equivalent EMF now, N minus 2 into E minus 2 into E. This is E equivalent, and that is equal to I into R equivalent, which is I into R equivalent will be N minus 2 into R plus 2 into R. So it will become N into R. So N E minus 4E is equal to I into N R. So I is equal to E common N minus 4 by N into R. This is I. So we have to find the potential difference across cell A or B. If we draw the cell A, so it is looking like this. This is cell A and the current is going like this. So this is charging. This cell is getting charged. Okay, current is going through positive terminal. So if we consider these points P and Q, so we have Vp minus Vq is equal to minus E minus I into R, or we can also say Vq minus Vp is equal to E plus IR. So we'll get positive number. So this will be equal to E plus IR, and I into R is equal to E into N minus 4 by N. So E common will get 1 plus 1 minus 4 by N, then E into 2 minus 4 by N, 2 common, so 2E into 1 minus 2 by N. So that is the answer. Now next, look at question number 8. In the circuit element given here, if potential at point B is 0, potential of A and D we have to find. So potential of B is mentioned 0, and the direction of current is also mentioned. Current is 1 ampere. It is going from A to B to C like this. So we will use Kirchhoff's voltage rule. So we can write VA minus VB is equal to, now you go from A to B, go A to B. So this is voltage drop or potential drop. So we'll get plus IR because along the current we are going. Along current use plus IR. So this is 1 into 1.5. So we have VA minus 0 is 1.5. So VA is equal to 1.5. Now similarly, you see C to D, but we don't know C. Potential of C we don't know. So B we know. So B to D you consider. So VB minus VD. So go B to D. So along current we are going. So again plus IR. So 1 into 2.5. Now we are getting negative terminal of cell. So that is minus 2. So 2.5 minus 2. So that is 0.5. So VB is 0. 0 minus VD is 0.5. So VD is equal to minus 0.5 and VA is equal to 1.5. Okay, so fourth option. Next. Now look at question number 9. We have potential difference between points A and B of adjoining figure. So we have to consider this circuit. So VA minus VB. So you observe this is the cell, this 2 volt cell. It is connected across this series combination and this series combination. So if you consider this series combination, so equivalent is the 15 ohm. If you consider this series combination, that is also 15 ohm. So to find current in this branch, we can directly take, suppose this current is I. So this full EMF we are getting 2 volt across this 15 ohm. So I is equal to 2 by 15. That is the current. So VA minus VB, you go from A to B along current. Current is also A to B. So that will be equal to 5I plus 5I or 10I. So 10 into 2 by 15 or 2 into 2 by 3. So 4 by 3. Next. Look at this 10th question. We have 7 resistances connected as shown. What is the equivalent resistance between A and B? So we have to identify series and parallel, and if it is a Wheatstone bridge also, then we will see. So this 6 and 6 are in parallel, and this 10 and 10 are in parallel. So we have this is 5. Now we have here a 5, and this is 8, 3. Now this 6 and 6 are in parallel. So this is 3, point B and point A. So this is a Wheatstone bridge now. 5 by 5 is equal to 3 by 3. So we can remove this 8 resistance. Then this 5 and 5. 5 and 3 will come in series. And this 5 and 3 will come in series. So we have 8 and 8 in parallel. So equivalent is 4 ohm. Okay.